We now begin to solve rational equations. I want to pay attention to the fact that these are equations and not expressions, which is something I'm going to talk about at the end of this video. The key idea here is that we're going to clear the fractions by multiplying through by the least common denominator. And we're also going to have to be careful to check that our answers work. Notice in this first equation down here, if x were 0, we would be dividing by 0, and we have to watch out for that because that gives us an undefined situation. So what we're going to do here is we're going to look at all three of our denominators, and we're going to multiply through by their least common multiple, which is 8x. Now technically we are multiplying the left side by 8x and the right side by 8x, which is going to distribute through, but most people like to write this in all three positions so they've got something to physically cancel with. Notice in the left the x's are going to cancel in that first fraction, leaving 8 times 4, which is 32. In the center the x's are going to cancel again, leaving 3 times 8, which is 24, plus, and then on the right the 8's are going to cancel, leaving just 1 times x, which is x. Subtracting 24 on each side, we get x equals 8. Notice when we substitute 8 into the original problem, 4 over 8 equals 3 over 8 plus 1 over 8, which is a true statement. I don't like that I've crossed out these x's, however, because I can't see my original problem as well. So I'm going to just write down my least common multiple that I'm going to be multiplying through by, but I'm going to be a little bit more careful on these future problems, doing the cancellation mentally instead. In this problem, the 12, the 3x, and the x all go into 12x. So I'm going to multiply through by 12x on each side. On the left, the 12's are going to cancel, leaving x times x, which is x squared. In the middle, the 3x is going to cancel with the 12x, leaving 4 times the x plus 3 that's there in the numerator already, equals, and on the right, the x's are going to cancel, leaving 1 times 12, which is 12. We now have a quadratic equation. We need to set that equal to 0, but first we're going to need to distribute on each side. So we're going to have a 4x plus 12 on the left. The 12's are going to cancel out when you subtract them off of each side. So that leaves x squared plus 4x equals 0. That can factor into x times x plus 4, which gives us two solutions of x equals negative, or let's do the 0 first, or the negative 4. Notice, however, that the 0, when substituted in, does not work. It gives us a 0 in the denominator, which is an undefined situation. We're going to say that this is an extraneous solution. Sometimes it's called an extraneous root, and we're going to cross it off. Only negative 4 is the solution to that equation. Extraneous solutions are a lot like weeds that just kind of pop up in the middle of your problem, and we need to get rid of. Okay, next problem. We notice that the first denominator will factor into 4 times n minus 1. That will be the least common denominator of the problem. So we're going to multiply through by 4 times n minus 1 on both sides. Just for simplicity, I'm just going to write it the once. On the left, the whole 4 times n minus 4 cancels, just leaving 2. Minus, now in the middle fraction, the 4's cancel, so you've got just the 7 that was there already, times the n minus 1 that's left over. Equals, on the right, the n minus 1's cancel, so negative 3 times 4 is negative 12. We're now going to do a little bit of distribution. We've got 2 minus 7n plus 7 equals negative 12. Combining like terms, 2 plus 7 is 9, so negative 7n plus 9 equals negative 12. Subtracting 9 on each side of the equation gives us negative 7n equals negative 21, and dividing by negative 7 gives us positive 3. 3 is an allowable value, not restricted in this problem, so it is our single solution.